Hi, welcome back to Algebra 1. This is Unit 1, Lesson 2, the order of operations and evaluating expressions. To start off today, we're going to look at some essential knowledge. The things we need to understand here are what a power is. A power has two parts. It has a base and an exponent. Many of us have seen exponents before. What an exponent does, it tells us how many times we're going to be using the base as a factor for something. So in this case here, I have 2 with an exponent of 3. That means I have 2 times 2 times 2. I'm multiplying the number 2, the base, by itself 3 times. Not to be confused with 2 times 3, where 2 times 3 is 6. This is 2 3 times, which is 2 times 2, which is 4, times 2 again, which is 8. We can read 2 to the third power as 2 to the third power, or 2 cubed. To simplify a power, what we mean by that is we're going to replace the base and exponent with a single value. So in this case we have 2 cubed, or 2 to the third power. That equals 2 times 2 times 2, and as I said before, that's 2 times 2, which is 4, times 2 again, which is 8. Alright, here we're going to simplify some powers. So first of all, to simplify a power means, again, to write it without the exponent as a single number. So here I have 10 to the 7th power. Remember, that means 10 times 10 times 10 times 10 times 10 times 10 times 10. So 10 times itself 7 times, not 10 times 7. What you're going to want to do is get your TI-83 calculator out, and you're going to punch in 10, and then there's it's called a caret. It's the button above the divide symbol. You're going to push that and then push 7. So it should say 10 caret 7 in your calculator, and go ahead and push enter. What you'll get is 10 million. So as you see, 10 to the 7th power is 10 million. 10 times 7 is 70. So there's a huge difference there. These aren't even close to being the same thing. Let's try this. 0.2 to the 5th power. So again, using your calculator, you type in 0.2 and then the caret symbol. It's the button above the divide button. It looks like a roof. And you're going to push 5 for the power. So that's 0.2 times 0.2 times 0.2 times 0.2 times 0.2. And you should get 0.00032, a very, very small number. Go ahead and use your calculator to try and figure out these next two. 3 to the 4th power and 2/3 all to the 3rd power. 3 to the 4th power should be 81. It's 3 times 3 times 3 times 3, and that's 81. Now, 2/3 to the 3rd power. If you want to type this in your calculator, you would have to push the left parenthesis button, then 2, then the divide button, then 3, then you'd have to close the parenthesis, push the roof button, or caret button, and then 3. That says 2 divided by 3, which is 2/3, all to the 3rd power. When you push enter, you'll get 8/27. The neat thing here is what's happening when we multiply fractions is we're multiplying straight across. So 2 times 2 times 2 is 8. That's 2 cubed. We saw that in the last slide. Also 3 times 3 times 3, that's 3 cubed. That's 27. So when you cube a fraction, you're cubing the top and the bottom numbers. Alright, so we're going to want to use all of this idea of simplifying when we deal with numerical and algebraic expressions. But before we can do that, we have to establish a set of rules or an order by which we perform all these operations. Some of you may have heard of the order of operations before, and people call it PEMDAS, P-E-M-D-A-S, which stands for parentheses, exponents, multiply and divide, then add and subtract. There's also this acronym, please excuse my dear Aunt Sally, that some people use to remember the order in which all of these things happen. Again, the first letter, so parentheses, exponents, multiply, divide, add, subtract. What you really want to be thinking of is when you're doing this, you want to perform any operation that's inside grouping symbols like parentheses or brackets. Then you want to go ahead and simplify any powers like what we just did. After that, go ahead and multiply and divide from left to right. So it's not multiply first, then divide. It's do all the multiplying and division from left to right. And finally, you take all of the whatever's left over and you add and subtract from left to right. Once again, you don't add first and then subtract. You do whatever comes first, going from left to right. In this example here, we have 2 to the 4th power minus 1 all over 5, or divided by 5. So first I look for any operations inside grouping symbols. There aren't any. So then I go to step 2, simplifying powers. Well, there is a power here. It's 2 to the 4th power. Remember, that's 2 times 2 times 2 times 2. So you can use your calculator to type 2 caret 4, and you should get 16. Now I'm simply going to replace the 2 to the 4th with 16. I simplified that. Now I have 16 minus 1 divided by 5. Well, the 16 minus 1 is in a group on top, and this 5 is in its own group on bottom of this fraction. So I can't divide yet because I have to perform any operations inside a group. So before I can do any kind of dividing, I'm going to simplify this top part, make it 16 minus 1, and down here you see that's 15. So now I just have 15 divided by 5, so I'm down here at step 3. Multiply and divide from left to right. Well, there's only one thing happening to divide. It's 15 divided by 5, and that equals 3. So now I have simplified this expression. Let's look at number 2. 6 minus 2 in parentheses, all to the 3rd power divided by 2. Alright, so again, the key concept here, number 1, perform any operation inside of grouping symbols. So I'm going to take care of this first, this 6 minus 2. If you notice over here, that 6 minus 2 has now become a 4. 4 to the 3rd power divided by 2. That's the only thing I've changed, one step at a time here. Now I'm going to look for any kind of grouping symbols. Well, I do have these parentheses, but nothing's going on in it. And the next thing I have is a power. So that's step 2 up here, simplifying powers. 4 to the 3rd power means 4 times 4 times 4. You can do 4 caret 3 in your calculator, and you get 64. Notice this divided by 2 has just kept coming along for the ride. I haven't done anything with it yet. Now in this step, I have 64 divided by 2. You can punch that into your calculator, and you get 32. Alright, now that we've learned about the order of operations, we can start to evaluate algebraic expressions. When we evaluate an algebraic expression, we replace the variables within the expression with a given number. Then what you want to do is simplify the expression just like we did previously using those order of operations. So for example, we want to evaluate this expression down here. We want to find the value of the following expression when x equals 5 and y equals 2. So when I look at this here, this expression, this algebraic expression, I notice that there's x's and there's y's. So what I want to do first is I want to replace the x's with the number 5 and replace the y's with the number 2. So here they are. Where I had x squared, I now have 5 squared. Where I had just x, I have just 5. Nothing happened with this 12. And this divided by y squared now says divided by 2 squared, because y was 2. Now I can start to use the order of operations, just like we previously did, to simplify this expression. Remember, I would first look for grouping symbols, which I don't have any of those. And the next thing I want to do is move on to anything with exponents. So I do have two things with exponents here, two bases with exponents. This 5 is squared and this 2 is squared. So as you see right here, this 5 squared is now 25, and this 2 squared is now 4. The next thing I want to look for is any multiplying or dividing that's going on, starting from the left and moving across to the right. So as I scan across here from left to right, I don't have any multiplying or dividing until I get to here. And this is negative 12 divided by 4. So what I want to do here is I want to divide this negative 12 by 4, and I get negative 3. So this became this 3 here. Now I have adding and subtracting, so from left to right I want to add and subtract. So first I do 25 plus 5, and that's 30, and then I subtract the 3 from 30, and I get 27. Alright, so how does this all come together? Well, we have to be able to evaluate real-world expressions. So we have real-world situations that we want to be able to use the skills that we've just learned now to figure out exactly what's going on. So here's a great question. We want to come up with an expression for the spending money that you have left after depositing 2/5 of your wages into savings. So we're going to evaluate the expression for weekly wages of $40, $50, $75, and $100. So whenever we have a word problem, we should break it up into a couple of parts. We want to know what do we know, we want to know what do we need, and we got to come up with a plan. Okay? Without these three things, word problems are extremely difficult. So first off, what do we know? Well, we know a couple things here. We know that the savings is 2/5 of my wages. And I know that there's various weekly wages, $40, $50, $75, and $100. So the savings is going to be 2/5 of my wages, which means my spending money is going to be something else. So what do we need? Well, we're going to need to find an expression for our spending money. Okay? And we're also going to need to find out the amount of spending money for each of these different wages. And how are we going to do that? Well, we should write an algebraic expression, and we need to evaluate it for each amount of the weekly wages. Down here, we're going to use this table to try and organize our results. Tables are a great way to visually organize what's going on. But first, before we can organize anything, we have to figure out exactly there's some things we need to figure out here. So first of all, we have to realize our spending money is going to be the wages that we've made minus whatever I put into savings. So everything I make minus whatever I put into savings is what I get to keep to spend. So I know my savings is 2/5 of my wages. So really, it's my wages minus 2/5 of my wages. Whenever we see this word of here, we always think multiply. Of in math is going to almost always refer to multiplication. That's going to be important here. So we're going to define something. We're going to say let W equal wages. Well, because I'm not going to write a math equation with the word wages in it. I want a variable. So I'm defining a variable to be my wages. And I just happen to pick W because it has the same starting letter as wages. This is called a let statement. So let's see. So when I use this W in for the word wages, I see my spending money equals W for wages minus 2/5 times wages. So 2/5 W. Remember, anything next to a variable, when a coefficient or a number is in front of a variable like this, it automatically means multiply. So this says spending money equals W minus 2/5 W. So that is going to be my algebraic expression for how much spending money I have. So let's start with our wages. The first one says $40. So $40 is my W. So let's put that into this equation. 40 minus 2/5 times 40. So how do I evaluate this? Well, first thing I need to do is look for any parentheses, any kind of grouping. There's nothing to be done in here. But the next thing I need to do is anything that has to do with multiplying or dividing. So I'm going to do the multiplication of this 2/5 times 40, and then I'm going to take 40 and subtract that from it. So go ahead and use your calculator and do 2/5 times 40, and then take 40 and subtract that answer. You'll get 24. Likewise, I'm going to do the same method for both $50, $75, and $100. So at $50, my equation, or I'm sorry, my expression would look like this. 50 minus 2/5 times 50. And that works out to be $30. At $75, I would have 75 times, or minus 2/5 times 75. Again, remember, we're doing this part first, and then we're subtracting it from 75. And I get $45. Finally, 100 is going to be 100 minus 2/5 times 100. And that's $60. When you're doing this in your calculator, I recommend doing it in parts. First, do this 2/5 times 100, and then take 100 and subtract that answer. Trying to type it all into your calculator can work. It's just you're more likely to make a mistake somewhere along the line with the order of operations with your calculator. Alright, so once again we've come to the conclusion of another lesson, and we have to do a check your understanding. So you're going to answer this question on a separate sheet of paper to bring to school tomorrow so that I can take a look at it and make sure that you are able to really understand what was going on in this lesson today. I think it will be very helpful for you when answering this question to actually pause this video and go back and take a look at that table if you didn't just write it down that was on the previous slide, because that table will help you significantly in doing this question. Well, good luck and have fun, and I will see you all tomorrow.